Alright, happy Monday. I just realized my face is on the title there. So since so many of you stayed home because, I don't know, for some reason the buses didn't come to pick you up, I thought I would make a real quick video on solving equations using logs and exponents. And I decided that I have to add this and exponents because sometimes it's easier to just figure it out exponentially. Alright, so we're going to look at solving two equations here. One where you can just rewrite the two exponential expressions with the same base, and the other where you actually have to use a logarithm. And that's going to lead us into what I skipped in the last lesson that I really need you to know. So the other thing we're going to cover in this video is the change of base formula is what it's called. Okay, so suppose I have 8 to the x power is equal to 2 to the x plus 6 power. Well, there's a little principle that we can use, and it goes like this. It says, if a to the m power is equal to a to the n power, then m has to equal n. So the only way this works, though, is if I have the same base. So when I look at my 8 to the x power and my 2 to the x plus 6 power, I have to ask myself, okay, is there a common base there? And it turns out, yes, 8 can be rewritten as 2 to the third power. So I have 2 to the third to the x power, which is equal to 2 to the x plus 6 power. Now, using our properties of exponents that we learned so long ago, we're going to say, well, when I have 2 cubed to the x, when you have a power to a power, you multiply the powers. So now I have 2 to the 3x power is equal to 2 to the x plus 6 power. Now, based on this rule right here, if the bases are the same, then the exponents have to be the same. So that means I can write without any concern or doubt that 3x indeed is equal to x plus 6. And then when I subtract x from both sides of the equation, I get 2x is equal to 6, and then x has to equal 3. And so now I found my value. Now it's always a good thing to go back and test this. 8 to the third power and 2 to the ninth power. Well, I'm going to get out my handy dandy calculator here. And when I calculate 8 to the third power, I get, I don't know if you can see that or not, 512. Okay. So 512. And I know that 2 to the 9th is also 512 because 2 to the 10th is 1024. But, just for kicks, I'll calculate it on the calculator and show you that. I don't know if you can see that I did 2 hat 9, but it does indeed say 512. So that is solving an equation, an exponential equation, using exponents. Now, if there's no possible way to write my two exponential expressions with the same base, then I have to use a logarithm. Okay? And this goes back to the rule I introduced at the beginning of the year. If you do something to one side of the equation, you have to do it to the other. Well, taking the log of both sides of an equation is something you can do. So I'm going to look at this problem. 5 to the x minus 2 power is equal to 200. Now, get my face out of the way here, put it over here. So if I have 5 to the x minus 2 power, well, 5 is a prime number. That would be the base. I don't have any way to write 200 as a base of 5. So what I'm going to do is I'm going to take the log of both sides. And because your calculator calculates the log in base 10, I'm going to use the log in base 10. Okay. So I will have the log in base 10 of 5 to the x minus 2 power, and that has to equal the log in base 10 of 200. Now, our properties of logarithms last week told us that if we have a power inside a log, we can rewrite that as a multiplier. So I'm going to take this x minus 2 as that is a power, and I'm going to multiply it by the log. So I have x minus 2 and the quantity of x minus 2 times the log in base 5 is now equal to the log of 200. Now I want the x minus 2 by itself, so I'm going to divide both sides of my equation by the log of 5. And I just realized I said the log in base 5 up here. I mean the log of 5, it's not the base 5, it's the log of 5. I apologize for that. So anyway, if I divide by the log of 5 on that side, I have to divide by the log of 5 on this side. And so now I have x minus 2 is equal to the log of 200 divided by the log of 5. And I add 2 to both sides. And so when I do that, minus 2 cancels here, and I get plus 2 over there. And then by plugging log of 200 divided by the log of 5 into my calculator, I should get 3.292 about, and then when I add that to 2, I get approximately 5.2. Okay. So this is a calculator problem right here. You will need a calculator to evaluate that. But that leads us to our last idea for this video. And that last idea is this one. And I have to change the page, so hang on. Okay, so we have the change of base formula. Now, if I want to write the log in base 5 of 200, okay, because in that other problem, I could have done that. Take the log in base 5 because that will cancel the log's base. Well, this simply, by the change of base formula, says, well, you know what, you can write that as the log of 200 divided by the log of 5. Now, how do I say that in general terms? Well, as a general rule, this is probably something you're going to put in your notes for the test. And that's the wrong form of 2. Wow, it's been a long, long time since I made that kind of error. Okay. Oh, wow. All right, so to write the log in base b of m in log base c just take the log in base c of m divided by the log in base c of b. Okay. So basically you take the log of the number divided by the log of the base. And since our calculator uses base 10, that's going to be the most common log that we change to. Now the other one, and we haven't talked about this yet, but we'll be getting into it very quickly, is the natural log. So if I have ln, which is the natural log in base e, I can do the same thing. The natural log of m divided by the natural log of b. Okay? And it really doesn't matter. So go ahead and practice that. I want you to write the log in base 2 of 40 in base 10. Okay. So think about that for a minute. You're going to start off, you're going to take the log of 40, because you always take the log of the number you're finding the log of. So log of 40 divided by the log of 2. So that's how you can use your calculator to calculate the log in base m, or in a new base, by converting it to base 10. You just take the log of the number that you're finding the log of in base 2 divided by the log in base 2, or the log of the 2, and that will give you your answer every time. Okay. So that pretty much is all there is for this lesson.